Hello and welcome to the first section of Chapter 6. We're going to be working with ratios, proportions, and I'm going to briefly mention this thing called the geometric mean. It's a fancy word for something that's pretty easy actually. So let's just go back. You guys have seen this. Ratios, basically it's a comparison of two different numbers. So we're going to be comparing side lengths of different triangles. So the ratio of the side lengths from these two triangles is 2 to 1. You can write it in word form, fraction form, or using colon. And we always express ratios in simplest form, so we're always going to reduce them. So if we're comparing the width to the length, for example, in this rectangle here, we have 7 to 14. That reduces to 1 to 2. They're called equivalent fractions or equivalent ratios, but our final answer is going to be simplified or reduced. So simplify the ratio, 64 to 6, I would divide this by 2 and get 32 over 3. This one, be careful with here, the units need to be the same. Okay, so 5 feet is really 60 inches over 20 inches, so we have 3 to 1. Or 3 over 1, or 3, your call, your pick there. But just make sure that you put the units in the same units, so convert the feet into inches. You could convert inches to feet, but then you got a decimal, and that's a lot of work. I would refrain from working with the decimal. I'm planning to paint a mural on a rectangular wall. You know that the perimeter of the wall is 484 feet, and that the ratio of its length to width is 9 to 2. This, by the way, is a picture downtown Minneapolis. Maybe you've seen it. It's a mural of it's just music sheets there. I took that picture a while ago. I just thought it was kind of cool. Find the area of the wall. So basically, you have this rectangle, and the ratio is 2 to 9. There's tons and tons of these problems where they give you the ratio of the length to width. So we're going to call this 9x, and we're going to call that 2x because it's a 9 to 2 ratio. This here will be 2x, this here will be 9x, and so we're dealing with the perimeter. We're going to add up all 4 lengths. So we have 9 plus 9 plus 2 plus 2, so that's 22x equals 484. Divide by 22, that will give us x. So let's see, 484, 22, 2, 44, 4, 22. So x equals 22. Sorry about all my mumbling there. So x equals 22, find the area of the wall. So this would be 44, and then we do 9 times 22 to get that. $198. My smartboard's being a little slow here. So 198, and then you could do the area is equal to 44 times 198. So first find the length and the width, and then calculate our area. All right, a triangle's angles measures in the extended ratio of 1 to 3 to 5. Find the measure of the angles. Okay, these problems come up a lot as well. So you have extended ratio 1 to 3 to 5. So you can do 1x, 3x, 5x. A lot of questions like these, very, very common. So we have, if we know the sum of the triangle is 180, so we're going to add those 3 angles, and that would be 9x. And we're going to set that equal to 180 degrees, divide by 9, and x equals 20. So it says find the measures of the angle. So this one right here is 20, this one right here is 60, and this one right here would be 100. So that's an extended ratio. And then we have proportions, solving proportions. You guys have seen this. It's the cross product. The product of the extremes equals the product of the means. You don't really need to know which ones are extremes, which ones are the means. You just need to know how to solve a proportion. So the cross product is where you do A times D equals B times C. This guy right here. All right, I'm going to do a couple problems. So we'll do 2 times 8 equals 5 times x, so 10 equals 5x. Divide by 5x equals 2. Some of them are easier than others. 3x times 1 equals 4 times x minus 3. When you're doing a problem like this here, where there's 2 terms, make sure that you apply the distributive properties. So you're going to be using parentheses there. And I'm going to pause my video right here because I've student. Okay, picking up where I just left off, going on to the third example here. Oh, by the way, I forgot to mention, you can check all these answers. You can plug them in. So I was just looking at this one right here, and I realized I made a mistake because I couldn't read my handwriting. That's supposed to be a 6, and you end up with 16 over 5. And I knew that was wrong because when x was 2, 2 over 2 does not equal 5 over 8. So these are easy to check because you can plug in your answer that you get for x or y or whatever variable you're working with and see if you're right or wrong. So I quickly glanced at that one and was like, yeah, I'm definitely wrong on that one. So 14 times y minus 3. Notice I'm using parentheses there. 7 times y. So it's 14y minus 42 equals 7y, and then I will subtract the 14y to get negative 7y, and then divide by negative 7 to get 2. Hopefully the background color is okay on that green. Okay, and then there's tons of word problems that you can do with ratios and proportions. As part of an environmental study, you need to estimate the number of trees in a 150-acre area. You count 270 trees in a 2-acre area and notice that the trees seem to be evenly distributed. Estimate the total number of trees. So in 200, okay, this is a really bad color. Let's switch this. Okay, in just 270 trees in 2 acres. Okay, so that means we can set up a proportion to figure out how many are in 150 acres. So we'll just put X amount of trees. And it says it's because it's evenly distributed. So 2X equals 150 times 270. That's a big number. And then divide that by 2. That will give you your answer for the number of trees in 150 acres. I'm just going to talk about this. The geometric mean of two positive numbers, a and b, is the positive number x that satisfies this proportion. I'm just going to show this to you guys. I don't really know if it comes up that often. So find the geometric mean of these two numbers. So what you do is you do 12 over x equals x over 27. And then you cross multiply and you get x squared equals whatever 12 times 27 is. And then you square root both sides. So whatever this number is, this is what's called the geometric mean. It comes up one other spot in the book. Just in case you ever see it, this is what it is. I'm not gonna be too picky on this, but I wanted to show you guys this in case it were to come up. All right, and then here's your assignment. I've marked a lot of these with stars just because I think they're kind of fun problems or a little more tricky than others. Let me know if you guys have any questions. Thank you for the start of Chapter 6.